Okay, at the end of the last video, I started going over modeling, evaluating, and graphing two-step inequalities in one variable. So it says Janelle is at the movie theater and she has $20 to spend. She spends $8 on a ticket and wants to buy some snacks. Each snack costs $4.99. How many snacks X can Janelle buy? Here's the inequality that represents this situation. So I would want you to rewrite it. No, you know what? Just leave it as is. 20 is greater than or equal to 8 plus 4.99x. In order to solve, I need to subtract 8 from both sides. These 8's cancel out, and I'm subtracting because this 8 is positive. You can't see it, but I need the opposite. I can't have plus 8 and then plus 8 because positive 8 and positive 8 is 16, and I need this to equal 0. 20 minus 8 is 12. It's greater than or equal to 4.99x. Then in order to get rid of the 4.99, I'm going to divide by 4.99 on both sides. Whoops, 99. And divide by 4.99 over here. Cross this out. X is less than or equal to 12 divided by 4.99, which I divide by 5 because 4.99 is close to 5. 5 and 12 is 2. Add a decimal. 2 times 5 is 10. 2, 5 and a 20 is 4. So 2.4 is my answer. X is less than or equal to 2.4. So now over here, drag each number to show if it is a solution to both the inequality and the problem situation. The inequality is this right here. Boom. The situation is Janelle going to the movies and wanting to know how many snacks can she buy. Can you buy 4/10 of a snack? No. She can get 2 whole snacks. She can get 1 whole snack. That should be a 2 right there, but it looks a mess. So 2 or 1. Or she can get no snacks. But can she get 3 snacks? Absolutely not. That's more than the 2.4. Okay? So, solution to both the inequality and the situation. So, the solution to the inequality, this is where I would allow you to use your calculator as well to double check your work. 12 divided by 4.99 is 2.41. So that's my exact solution, or 2.40. I can leave it as is. So, a solution to the inequality and the situation. Can I get 2.3 snacks? No, but it's just a solution to the inequality. Can I get 2 whole snacks? Yes. Can I get 1 whole snack? Yes. Can I get 3/4 of a snack? No. But is it still less than 2.4? Yes. 2.5. This is not a solution at all because it's more than the 2.4. And this -4 is a solution to the inequality because if I were to make a number line, remember we learned how to graph these. My answer is 2.4 greater than or equal to x. On a number line, 1, 2, 3, 4, 5, 6, -2, -1, 0, 1, 2, 3. This 2.4 would be right about here. I would draw it with a closed circle, and I would want it to be my greatest option. So everything to the left will work. Eventually, I will get to -4. But it is considered a solution. 2.5 is not a solution because 2.5 would be right here in blue. 2.5. Remember, to the inequality and the situation, meaning, can she get this many snacks? Can I get 2.3 snacks? No, the 2.3 does not belong over here. Can I get -4 snacks? No, because you can't go to the movies and say, can I get -4 snacks? Check. Next. Eric is adding water to a 60-gallon pool. The pool already has 12 gallons of water, and he wants to fill it to at least 27 gallons. The water flows at a rate of 6 gallons per minute, so that's my 6x. How many minutes X will it take Eric to fill the pool with at least 27 gallons of water? The inequality that represents this situation shows 27 is less than or equal to 12 plus 6x. To solve the inequality, you can begin by solving the equation as shown. So they take out my equal sign here, or take out my inequality and put in an equal sign. They subtract 12 from both sides, then they get 15, and they divide both sides by 6. 2.5. This is how many minutes it will take, because the number of minutes is x, to fill up this to at least 27 gallons of water. So here I need to bring back my inequality sign over here. So 2.5 less than or equal to x. If you want to rewrite this, x, the alligator has to open toward the x because that's what it's doing here. And then 2.5. Then I graph it on my number line. 0, 1, 2, 3, 4. And 2.5 is between 2 and 3. So boom, and it's a closed circle because it includes the 2.5. It's got this number line, or this underline here. And then I want it to be greater. Whoops. Boom. That thing. Alright, so let's look here and see what we have. Alrighty. All possible solutions for the inequality. That means this and everything that's needed. Now remember, he's filling up a pool. So is he going to want to go more than 2.5 minutes? No, because he wants to get at least 27. So he's going to probably want to stop there. So which answer matches this? This one right here. This one doesn't work because it starts at 0. This one because it starts at 8. This is between 2 and 8. And this is just no. Alright, so all possible solutions for the problem situation. So I'm assuming that the problem situation would change this number here to a 60. But let me double check. Hold on. So here's how to check to see what fits the situation. Now it says there's a maximum of 60 gallons in the pool, so I can't go over 60. So I'm going to rewrite my inequality, but I'm going to take out that 27 and put in a 60. 60 less than or equal to 12 plus 6. Then I'm going to solve 6x minus 12 minus 12. This becomes 48 less than or equal to 6x divided by 6 divided by 6. 8 less than or equal to x. So it has to be between 8 and 2.5. So now finding the answers, which one shows between 8 and 2.5? This one here. The reason for this is because I cannot go more than 8 minutes because my pool will overflow. Again, that's matching the situation. Where's the check button? Oh, boom. Check. Did it work? Yup. Next. All right, here, Paulo is solving the inequality 15 plus 2x is greater than 31. To solve the inequality, he begins by solving the equations as shown. Which number line represents the solution to the inequality? Save. So they subtract 15 from both sides, then divide by 2, x is 8. Then we need to bring back the symbol, so x is greater than 8. And we're not including it because it doesn't have the equal sign or the half equal sign. So we've never seen answers like this before. Please don't choose this ever. It's never going to be correct. Here, this is x, which is 8, and everything greater. This is my winner. This is not it because this is 7. And 6, 5, 4, 3, 2, all the way to 0. That doesn't work. Check. Next. Kevin is saving for a new bike. He already has $65. That means he's going to have just 65. He's not going to keep adding 65 over and over and over. He just needs it one time. He makes $15 for each lawn that he mows. That means he's going to add 15 over and over and over for every lawn that he mows. The bike that Kevin wants to buy costs $175. So I need at least $175. Sorry, I'm speaking so quickly. Catch up, slow down. Which inequality could be used to find x, the number of lawns Kevin needs to mow to earn enough money to buy the bike that he wants? So I need to set it up. New, don't save. So I'm going to add the 65. So let's start with that. 65 plus 15x. So let's start there and get rid of what I don't have. This is what he already has, and then he's adding 15 each for each lawn. This is not it because we're not combining these. We don't ever do that. And this is not it because it's taking that 65 away. Over here, I've got these two left. I have 65x. Is he getting 65 for every lawn that he mows? Nope. But he is getting 65 for what he already has, and then 15 for every lawn that he mows. Check. It works. Next. Okay. Drag each number to show whether or not it is a solution to the inequality shown. So I've got 20x, or 20, greater than or equal to. 20 is greater than or equal to 5 plus 3x. Solve it. Draw your river. Subtract 5. Subtract 5. Wham. 20 minus 5 is 15. Greater than or equal to 3x. Divide by 3. Divide by 3. X less than or equal to 5. Boom. X is less than or equal to 5. Let me rewrite that. Ooh, my font is pretty large. X is less than or equal to 5. Numbers that are less than 5, 4, 3, 2, 1, 0, negative 1, negative 2, negative 3, and so on. So, boom, is this less than or equal to 5? Yep. Is this less than or equal to 5? Yep. Less than? Yep. Yep. This one? No. This is bigger than 5. This too is bigger than 5. Check. Next. Alright, Diana is solving the inequality. 2x minus 14 is less than or equal to 8. To solve the inequality, she begins by solving the equation as shown. Which number line represents the solution to the inequality? Bring back your inequality symbol. X is less than 11. I'm sorry, less than or equal to 11. So I want 10, 9, 8, 7, 6, 5, 4, 3, 2, and 1. Are these less than 11? Nope. This is just 11. Boom. These are less than 11. And this is just 16 to, no, this doesn't even start at 11. Absolutely not. Done. So at the end, it does not give me full credit here because I'm going through the Lesson Explorer. I got all the questions correct, obviously, but this is just an example of why you need to go on to the warm-up. We want this number right here to be very close to 175 so that we can pass the lesson. Make sense? Then we can go on to the warm-up. It's a game. Don't have to do it. You can get points for it, but great. Then here, in the guided learning, this is actually walking you through the problems. You can click Math Help here and get help from a real online teacher. I'm sure they're very busy these days. But this tells you what to do. Boom, it breaks it down for you with a diagram and a picture. Then this tells you how to make a table. And then if you still don't get it after you've tried answering the question, you can reach out for Imagine Math Teacher's help. Okay? Good luck, guys.